In this video, we will learn about implicit derivation. Here, before we begin with the problems, let me just tell you a little bit about implicit derivatives. Now, imagine we have a function x squared plus 3x minus 5. Okay, we need to derive this. That means d by dx. What does this exactly mean? We are differentiating or deriving with respect to x. So here, this power rule, it'll be 2x. And what is the function? We derive it as well. What is the derivative of x only? D by dx of x would be 1, isn't it? When we derive x term, it's 1. So we just don't write it as multiplied by 1. We just simply leave it because multiplied by 1 will be this value itself, isn't it? So 2 by power rule, the 2 comes down, power comes down, and over here reduce the power by 1, it'll be x itself. Then what about this? Plus 3, and when we derive x, it's again 1, so it's gone, and this is a constant function, so it's 0. So this would be the answer. The same concept is used even for y, but let me start with a simpler problem. Derivative of y, when we write dy by dx over here, since over here we have y, that's it, dy by dx is the answer basically. But since this is huge term, we denote it in a simpler way, that is y prime. This is how this is called Newton's denotions. So this is y prime or y dash. Y, that this prime is a single dash on the top like a apostrophe. This means it's derivative. So that's it. Now what if we have derivative of y power 2? Then derive the power first. 2y power 1, we don't write the 1, just 2y. And then we will have again y prime. Over here also we derive this x term, but it's 1, so we leave it. We leave it as it is. Over here we have to mention this y prime. Now what if it's y to the power 3 derivation? D by dx of y power 3 would be 3y power 2 into y prime. So these are some basic differentiation. Let me just write a few which really helps you out to compare. Now, if you have derivation, d by dx is derivation of say x and d by dx of y. And then let's try derivation of x squared, derivation of dx of y squared, and let's try another one, y cubed and x cubed. X power 3, and over here d by dx of y power 3. You can pause the video now, write the answers over here by yourselves, or you can continue watching if you are getting confused. See, this is x and we always derive with respect to x. See now here y prime of x means it's derived with respect to x, dy by dx. This is what it means. But we simply write it as y prime, or you can write y prime of x. That's fine. Now let me solve it up over here. This is gonna be, let me just remove that previous ones. So here let's use the power rule itself wherever we can apply. Otherwise we just use the rules which we know. If it's only x, it's 1. Here it will be 1 times y prime. I'll write only y prime. You can write y prime of x, but I'm just going to write y prime. That's fine. Here it's 2x. Here it'll be 2y, y prime. It'll be 3x power 2. Here it's going to be 3y squared, y prime. This is y prime or y dash. It means derived with respect to x. So if you compare these two, it's almost the same here, only a y prime is being added whenever we derive y. Whenever we derive y with respect to x, we have to add this y prime. This is the only difference. If you understand this concept, then these problems are going to be pretty simple. Now imagine this is like x only, but like another variable, how we derive x. If we have say cos x and then x power 3, we use product rule, right? So same way over here, imagine these are two separate terms, so we have to use product rule here and solve it up. So now here let's start solving it. I'll recall the product rule. Imagine a, b, this first term is considered to be a and second is b. You might also see it as u and v or any other thing. X and y also is fine. Just for your understanding, it's a prime b plus a b prime. or u prime v plus u v prime. Henceforth, I'll be using a and b for simplicity purposes, because my u and v sometimes won't be differentiable. So a and b is easily differentiable. I mean, you can understand the difference of it. So this is the product rule. Whenever two terms are multiplied, now here these two are multiplied. So what is the derivative of the first term? It'll be 2x. And what is this? Second term will be written as it is, plus, what about the second part? First term will be written as it is, and now we derive 2y. But don't forget, whenever we derive y, we have to multiply it with y prime plus 3y, but it's y prime here, equals 4. Why only 4? Because x will be 1. So that's the answer. I mean, it's not the answer, sorry. This is the first step. This is very important step. A lot of marks are awarded to this step mainly. And then the other simplification. Now, once you're done this, leave the y prime terms alone. Leave these over here. See, I'll write the two number first. X squared y prime. So you can keep it as it is, but generally what we do is numbers are written first and then the variables. So x and y comes later. And over here x squared y and y prime, isn't it? Plus over here we have another prime. See, I'll just mark them up. We have y prime here and here. So only these two terms are left over here at this side itself. And what is this? It's 3y prime. That is equal to 4 at the right side. Now, what about this term? Since it doesn't have y prime, we take it to the other side and it becomes minus 2x y squared. Now, here we can see this y prime and y prime both exist. And there's no other term without y prime. So let's take it as common term out. Y prime is removed common. So you're going to remain with 2xy plus 3, that is equal to 4 minus 2xy squared. Now y prime is what they have asked to find. Y prime, in the sense, it's y prime of x, okay, because it's all derived with respect to x. Now even for exam, if you write y prime, that's fine. I generally tell my students it's fine, because this is many of the students write it as y prime only. They don't write it as y prime of x. It's okay. If you can write it, then it's fine. Write it as y of x every way. I mean, over here when you derive it, y prime of x. So now over here, the above term, this term will be above over here as it is. But what about this term, which is multiplied here, moves to the other side from down? This is multiplication, goes to the other side and becomes the denominator, or divided. So it's 2x squared y plus 3. So this is it. So this would be the answer for the first one. Similarly, I will be solving many other problems. If you have understood it thoroughly, try to view a few more and then just move on. But I will try my best to solve all these problems. So that's how we do this. Now I'll remove all. I hope you have remembered these formulas over here. You can just write it out anytime and solve it by yourself, these formulas. So this was the answer, I believe. Yeah, that's it. Now over here, yeah, there's no problem. But sometimes, they might have the simplified form in the solution set. You may not be simplifying as much. It's okay. Don't worry about it. As long as you've got y prime alone and everything else on the other side, it's okay. That will be correct. Now let's solve this one over here. 3 outside. Again, we have to use product rule over here. A and B. See, AB would be equal to A prime B plus AB prime. So it is 3x. Okay, now derivative of x. Prime is the derivative, right, of the first term. Is what? 1. So it'll be 1 times y to the power 3 plus. Now a will be as it is. Derivative of y to the power 3 is 3y power 2 and y prime. Minus 4x x will be 1. So it's just minus 4 equals 10. This 2 comes down and multiplies with 10, so it'll be 20y prime. I hope this is clear. This is just basic derivatives. 2 comes down and multiplies with this 10, and therefore we get this 20. Y and y prime. Y over here, it's y only, because 2 minus 1 is 1. That will be y. Now here we will simplify and multiply this 3. I'll do step by step. Y to the power 3 plus, here 3 I'll write it at first, x y squared, and this is y prime. Now, why do we write this y prime of x as generally? Because y power 1 is not same as this y prime which I mentioned. So we just write it as y prime of x. So it's easily understandable. But as long as you are okay with it, you understand and differentiate it, that should be okay. That shouldn't be a problem, okay? Now, in my case over here, whatever I'm using y prime is this, okay? But I'm just not writing it everywhere. That's it. Now then, we will start solving the remaining part. Over here, minus 4 is equal to 20y and y prime. Now, our goal is to get all the primes together and then now everything else to the other side, isn't it? So what I can do is I can take this 4 to the other side, it becomes plus, and this part I'll get it in. You can do it in the next step, but first thing is we have to multiply this inside. It'll be 3y power 3 plus 3 times 3 is 9xy squared times y prime. And this I will take it to the other side of equal to, so it will be equal to positive 4. Minus becomes plus. And what about this? This becomes minus 20y y prime. Now then, here we need to group only the y prime terms. So I'll take this to the other side. It will be 9xy squared y prime minus 20y into y prime. That is equal to 4 minus 3 y cubed 9. Sorry, it's plus. Now, oh, I got drawn away. This is a single term, guys. It's 9xy squared y prime. Sorry, I shouldn't write that. Don't do the mistake which I did. It's just this term that moves to the other side. Just this first term to the other side will be 4 minus 3y cubed. Now here we can see y prime and y prime are same. So we remove it outside. And what is remaining? 9xy power 2 minus 20y are remaining equals 4 minus y 3y cubed. Now what else? Here take this entire term to the other side. So it's y prime is equal to 4 minus 3y power cubed. And we have 9x, this is x not multiplied, y squared minus 20y. So this would be the final answer in this particular problem. So it's basically you do the derivative. This is very important, applying the rules and making the derivative of the entire sides, all the terms. And then what you do is gather y prime to one side and everything else moves to the other side. That's it. So here we get the answers. It is now over here. You can see there is one difference. I'll tell you how why it is written positive 3y cubed minus 4 and positive 20y and minus 9xy squared. It's up to you guys. I would personally leave it like this and you should get full marks, no problem. But imagine you take a minus sign outside from here. If you remove minus, the signs are going to flip. It will be positive 3y cubed minus 4. That will be the first about term. And even over here, let's take a negative term out. So then you will have positive 20y minus 9xy squared. So this would be the case or situations. Now minus and minus cancel. So you are having 3y cubed minus 4 divided by 20y minus 9xy squared. I hope this is clear. This and this are the same thing. I've just rearranged it and I have written it over here. So that's how we solve it over here. That's the answers. Now we will solve the 7th question. Before we solve, I'll write some identities. The derivation of square root x is given as 1 by 2 square root x. The product rule we had done, a times b, when there are two variables over here. It will be a prime b plus ab prime. Let's solve it out. Here I'll directly use the identity. It will be 1 by 2 root of x and y, square root of x and y, multiplied with whatever is inside. What is inside? It's x and y. Now we have to use the product rule. Derivative of x is 1 times y plus x times y prime minus this 2 comes down. It's going to be 4 times 2. It's 8y times y prime. That is equal to 12. Now let's, now is this 12? So don't do the mistake I did. It is 0 here. So now what can I do? I have over here two terms. There is y and y prime. Can I directly remove y prime? No, it's not possible. So first let's multiply this inside this term over here. So it becomes y, I'm gonna multiply this here and here. 1 is just 1y is just y. So y divided by 2 times square root x and y plus x y prime divided by 2 square root x y minus 8y y prime, that is equal to 0. Now we can take this to the other side. Now I'm 100% sure in your textbook they generally don't keep fractions. So I will do this as the textbook method and then I will tell a shorter method. Now from here I'm going to change the color because your textbook solutions are generally the solutions, they require you to not have any denominator. They require to have everything in the numerator. So what you can do is, now you can see there is 2 square root xy, 2 square root xy. Now if you multiply everything over here by 2 square root xy, what happens? You multiply this by 2 square root xy, this and this cancel, so you're remaining with y. What about over here? You will have plus xy prime because it cancels again. But here you will have 8y y prime multiplied by 2 square root xy. That is equal to over here 0 times anything is 0. I hope this is clear now. Now what you can do is this y is over here, right? Take it to the other side. You will have y xy prime minus 8y. Now I'll just simplify this. What is 8 times 2 here? It's 16y y prime square root xy. That will be equal to minus y. Now you can see this y prime. So let's take it as common term outside, x minus 18y square root xy, because I've removed this y prime outside, and what is remaining? It's only x minus here 16y and square root xy equals negative y. Now the final answer would be y prime will be equal to this, whatever is multiplied to the other side becomes denominator. Now why did I remove this denominator over here? Because you already get a denominator when you simplify, but if you have two denominators it's just complicated, right? That's the reason. So the final answer would be y divided by x minus 16 y square root xy. So this would be the answer. Now here, just a quick reminder, let's understand one thing. This is the most desirable answer, but this is not only the correct, this is not the only correct answer. I will now remove whatever I've written over here in black and I will rearrange this over here directly and I'll solve it. Okay. Now this is correct, don't get me wrong, this is absolutely correct, but there is a simpler way I feel, which I will just show you now. Let me just take it all up. Over here it's all gone now. Okay. Now what we do over here is just take this term to the other side directly. That will be xy prime divided by 2 square root xy remains minus 8y y prime remains. That is equal to minus y divided by 2 square root xy. This entire term is to the other side, so we have added a minus. Now if you want, okay, is this minus for the entire term? Yes, absolutely. You can just write it over here. It's fine. It's the same thing over here, over here. Now then, y prime and y prime, I'll remove it as common term outside. So what remains is x by 2 square root xy minus 8y. Because y prime is removed outside, so you're remaining with x divided by 2 square root xy. And over here, y prime is gone, only 8y is equal to negative y divided by 2 square root xy. Now you can take this entire term to the denominator, but you can see it looks very shabby, isn't it? It will be y prime is equal to, the numerator will be y, negative y, denominator over here will be this 2 square root xy multiplied by x divided by 2 square root xy minus 8y. I hope this is clear. You can leave it over here. This is y prime. Over here we are dealing with y prime. This is y prime of x. But if you want to go further, you can just multiply this inside. What happens is this cancels off and you will have the same answer what we had. You can stop over here. You must technically get full marks here as well. But anyways, let me just write the final answer, what it would look like. Minus y divided by this multiplied inside, it cancels off, so x is remaining minus 8y. 8 times 2 will be 16. Sorry, let me write it as 16 square root xy. This is the same answer we got any method, but over here you can just stop at this particular method, so it'll be just 3 more steps. But since your fractions, it'll look a bit complicated, like too huge, you know. So that is the thing. So that would be the answer over here, and you can see that's the final answer. Now over here, see, we have, yeah, there's nothing wrong in this. See, what this is the answer. What we have done, what they have done over here is this minus sign is removed and this minus sign is removed, and they have just rearranged the signs. You can leave it like this itself, that's more than enough. They have just done one extra step. Since it's all writing exam, it's more than it's fine. You can keep it however. This is also the correct answer. I just realized there's question 8 as well. Let's solve it up over here. Now what I would do for this, it's trigonometric function, sine is cosine, so let me solve it up. Cosine xy, then what is xy derivative? Over here we did the product rule, right? It'll be 1y plus xy prime, that is equal to 2x plus 0. Now here then, since over here we have cosine, how would you go to simplify this? All you need is the same thing. You multiply this inside. This is y, right? It'll be cos xy times, this is a single term. Now, don't multiply this y inside here, because this is, let me just write over here. Cos x, imagine cos x multiplied by a plus b. This is going to look like cos x times a plus cos x times b, or you can rewrite this as a cos x plus b cos x. Okay, you don't multiply it as cos xa. This is the degree over here, right? That remains there itself. Cos x, you can't multiply. You multiply it as a coefficient. That's what happens. So here also, I can directly write this y over here. Why? Because this is not going to be multiplied here. It's a separate term. It's multiplied to it. Then plus, I'll write xy prime, and you have cos xy here as well. That is equal to 2x. Now, where is y prime? Only over here. So what I'll do is I'll take this to the other side. It's going to be cos y prime cos xy. That is equal to 2x minus this entire term, y cosine xy. Okay. Now, this y prime over here remains. And then leave y prime. What else? Take it to the other side. It's going to be 2x minus y cosine xy divided by x and this entire term cos xy, cosine xy. So this is the answer. This is a simple one. It's just that, if you know how to multiply this, it's very straightforward. But just remember this, these are coefficients. They are not multiplied inside the degree, not over here. They are multiplied as a coefficient. That's it. That will be the answer. So here are the solution. Now over here, there is no methods, guys. See, you should do the steps, okay? Don't just write this directly the answer. You won't get full marks. Please make sure what I've done over here, the steps are very crucial. You can move ahead along in your own pace, but I'm going to solve as many problems as possible here. Moving to the question 9, here you might be thinking, okay, we can directly use a by b, that is the quotient rule. That'll be a prime b minus ab prime divided by b squared, right? Yes, you can do it, but the answers matter. Answers vary. If you do that entirely, your answer will be entirely different than if you look carefully over here. There is only y. See, when we come to this problem, you can see the differentiation. Over here we can manipulate the question itself, because over here you have y, only y in the denominator. Let's multiply throughout by y and make this a single term. What I mean is, if you multiply throughout by y, this and this cancel, so you will have. Moving to the question 9, when you look at this, you might be thinking, okay, we must use a by b equals a prime b minus ab prime divided by b squared. That's the quotient rule, isn't it? But let's wait a minute. You can solve it like that, but it'll just be more complicated. Whereas there's a simpler way you can manipulate the question by just removing this y to the other side, or multiplying throughout by y. what happens is the question becomes x plus 3 equals 4x plus y squared y, and this y squared y, sorry, over here it will be y as well, because you're multiplying these both terms by y. It will be xy, and over here y squared y will become y to the power 3, isn't it? Y cubed. So you can rearrange this question easily to this. Or you can multiply throughout by y, the same thing, y cancels here, and you will be multiplying only y at the right sides for these two terms. Now let us derive it. It'll be so easy. See, 1, because x will be 1, equals 4. Over here you have to use the product rule, which we have used many times before now. 1 times y plus xy prime plus over here 3y power 2 into y prime. And now here let's multiply this 4 inside. It will be 4y plus 4xy prime plus 3y square y prime. Over here we have 1. And now let's take this 4y to the other side. It will be 1 minus 4y, that is equal to 4xy prime plus 3y square y prime. Now let's take this y prime common outside. It will be y prime into 4x plus 3y squared. And over here we have 1 minus 4y, isn't it? Let's take this whole thing to the other side. We get 1 minus 4y divided by 4x plus 3y squared. That is y prime. I hope this is clear. Now you might be thinking, why can't we use the product rule here? Yes, absolutely you can use, but the values will be different. But as long as you have done it properly, you'll get a different separate set of answer, but that is also valid. But this would be more desirable in the sense, whenever you look at the question and it's easily, solvable, easily rearranged, then do it like this. So that would be the answer. Now over here they have written this term first, and that's fine. It's the same answer altogether. You can write 3y squared first or 4x. It's fine. Now let's look at the right side here. In this case, I wouldn't go to remove this x plus y. Why did I do it over here? Because both the terms in the left side had the same common, same denominator. But here, if I'm going to remove it, then it's going to be 3x into x plus 2 plus y cubed into x plus 2. It's going to be such a big complication. So in such cases, I'm not going to do that. All I will do is, let me use the directly, let's differentiate on both the sides. That will be 3 over here, x will be 1 plus 3y squared multiplied by y prime, because this is 3y power 2. Then again y prime is multiplied, minus, here it is a by b, that is equal to a prime b minus ab prime divided by b power 2. Some students put this as plus, which would be wrong, and some students forget this b power 2. They just write b, or they use the derivation over here as well. So be careful with this rule. Now here what happens is, this is the above term, 4y is a. So I will have to derive it. It will be 4y prime. Now this entire thing, I'll write it together in the bracket, multiplied by b, that will be x plus 2 minus, this remains, 4y remains, and derivation of x plus 2 is just 1, so I'm not going to write it, divided by x plus 2 the whole power 2. That is equal to 10x squared. What happens over here? Derive it. 2 comes down, it will be 20x. Now, see, now we have to multiply this x plus 2 the whole square throughout. Why? Because we have over here a prime, right? So we can't have this denominator. And over here there is no prime. If in case we had prime here and prime here, then it would be different. We can just leave it and then rearrange it then. But see, there is prime here, no prime. So then what we have to do is we have to multiply this denominator throughout all the other terms. These two terms have it, so leave it. Whereas all the others, you need to multiply. Let me write from here. X plus 2 the whole square. 3 times x plus here. See, this prime is already there, so it will be y power 2. I'll write prime at the end. So it's x plus 2 the whole square multiplied by y prime minus. Now here we just write 4y prime. I'll multiply this inside. See here, minus is being multiplied to this term. 4, let me just write x plus 2. Okay, this is minus. But now look at the next term. This is already having a minus. So when I multiply this minus to this, yes, it became negative. But then I do this minus and minus, it becomes plus 4y. Do I have to write anything down? No, because this has already been multiplied, right, to the other term. So this is gone over here. Equals 20x times x plus 2 the whole power 2. Now then, what else we will do is, we will just keep the y prime terms. That is, see over here, this is having y prime, this is having y prime. All the other terms to the other side. So let me write 3y power 2 x plus 2 the whole square y prime minus 4y. Let me write y prime at the end, x plus 2 y prime. The reason is I'm going to remove this common out in the next step, equals 20x into x plus 2 the whole squared. This to the other side would be minus 3x plus 2 the whole power 2. And then what do we have here? 4y will be to the other side minus 4y. I hope this much is clear. And then we just take this y prime outside. And now basically you're remaining with 3y squared into x plus 2 the whole squared minus 4 times x plus 2 equals 20x into x plus 2 the whole squared minus 3x plus 2 the whole squared minus 4y. It's a bit lengthy one. And the last final answer would be y prime as this entire terms, 20x into x plus 2 the whole power 2 minus 3 into x plus 2 the whole squared minus 4y divided by, what happens here, 3y squared into x plus 2 the whole squared minus 4 times x plus 2. So this is the final answer. It's lengthy, but once you derive it, see, this is the most important step, deriving, and this is all rearranging basic algebra. So now once you do all this, here what happens? You're just grouping the y prime terms and then taking everything to the other side. Over here you can see they have not, see now they have not done this entire is answer. See, they have taken the y prime out, but they have not taken this to the other side. It's you can vary the answer. Now what I have done is very basic, just follow the methods and just take it to the other side. Now here you can see x plus y is there, x plus y, you can remove this common out and all that. You can manipulate this various ways. In your textbook, I mean in the solution set, they are manipulated differently. That's fine, it's up to you. Now, in fact, this one is the same as the previous one. You can see the same thing. So I won't solve this. Over here, you can see the more detailed answer. What we got is also correct. It's just that we can take these terms outside and rearrange and make it beautiful, like beautiful looking. That's it. But if you do this, it's more than enough. This is also the correct answer. You can compare the answers over here. Let's do these. Now, if you're thorough already, you can move ahead at your own pace. But I'll anyways try to solve all these. What is the derivation of e to the power x? The derivation is the same, e to the power x itself. Now here we have e to the power x. So it'll be chain rule and then product rule. It'll be first, when we derive this, it'll be e power x power 2 y. Y is in the numerator, guys. Multiply it with the product rule. What is the product rule here? Again, a b equals a prime b plus a b prime. Now it's always better to write the rule and solve it up, because even sometimes when I sometimes solve it directly, I might miss out a term. So that's why I generally write it out and easily solve it. So it's going to be differentiation of the first term, that is 2x multiplied by y plus, now here you keep the first term as it is and only derive the second term, minus e to the power y multiplied by y prime, chain rule. This is the derivation of e power y, but then y prime equals 1. Now here then multiply this term, ex squared y multiplied with this will be 2xy plus e again x squared y into x squared y prime minus ey y prime equals 1, which doesn't have any y prime term. This is the only one, right? So I will leave ex squared y, this term, x squared y prime and minus ey y prime equals 1 minus ex squared y multiplied by 2xy. because this doesn't have any y prime term. I'm going to remove this y prime common, and you're remaining with ex squared y multiplied by x squared minus e to the power of y. That is equal to 1 minus ex squared y 2xy. You can write this 2 over here ahead because the numbers are generated at the first. So that will look like this. 2 e to the power x squared y xy. Now in the writing exam you can leave this over here. It's all correct. It's fine, you know. And this one will be ex squared y x squared minus e to the power of y, and over here we have y prime. This would be the final answer. There might be any variations similar over here. You can have this minus sign removed and here and there, but as long as you understood how to derive and rearrange, that is more than enough. Now let me do this one as well quickly. Question 12 would be product rule here. So product rule, again, I'm just going to write it quickly, and it is the derivation of the first one, e to the power y plus x e to the power y minus what happens here. Again, it's a product rule, 3 outside. What happens here is y prime, because derivation of y would be y prime multiplied by sine x plus, now y remains. What is the derivation of cosine sine x? It's cosine x positive. Okay, and that is equal to 1. If it is cosine over here, it will be minus. So remember, that's very important, the signs. Now then, what do we want is, okay, is this now over here? Can you see I've done a mistake, right? The first one is derivation of x is 1 ey, and second part is a will be as it is. The derivation of ey will be ey and y prime. See, I just realized that just now. If I had not realized, then I would have done wrong, and then I would have traced back the mistake. It would be a long error. So just make sure you do this step very accurately. Now here I'm gonna remove this term to the other side because there is no y prime. I'll just leave this x e y prime term, and then I'm going to multiply this minus 3 inside here. It's going to be minus 3y prime sine x, and this is again minus 3y cosine x equals 1 minus e to the power y. Why? Because this goes to the other side. 1 times e power y is e power y itself. 1 minus e power y. And now y prime and y prime, let them be here. Y prime minus 3. I'll write sine x y prime. Because I'm going to remove this y prime, I'm going to rotate the end. This will be equal to 1 minus e to the power y. This, when it goes to the other side, it becomes plus 3y cosine x. Now what do we do here? We take this term common outside, x e to the power y minus 3 sine x. That will be equal to 1 minus e to the power y plus 3y cosine x. And lastly, the same thing at the right side, no changes here. 3y cosine x divided by this entire thing divided by e to the power y minus 3 sine x y prime. I hope this is clear. That's the answer. Now you can see the answers over here as well. If you're thinking, okay, see now here there is a little bit of difference, doesn't matter. Okay, now there is a huge difference, guys. I just forgot a very important thing. Please do not do the mistake I did in the exam. This is gonna be 0. Why? Because derivation of 1 is 0. I don't know what I was thinking when I was solving that. So this 1 is not there. Okay, even over here this is not there at all. Now that was a simple mistake. In this case didn't occur a lot of problems. Let's just look into the answer. You have 3y cosine x minus ey divided by, yes, that's absolutely right. Only thing what I missed was this 1 to be derived to be 0. In my case it's okay. I can write this term first and minus e to the power y, which is in the solution set, but this is also the correct answer. But if I'd missed something else over here, the left side, then it would have been a huge mistake. So this is how we solve it. And now we have again, okay, square root functions. I think so we have done one square root problem already. Anyways, let me do this as well. Here, it's not only square root, it's a product rule as well, isn't it? Now it gets a bit trickier. This is A, this is B. Let's use the product rule. It'll be a prime b plus a b prime, and here we will have 2y prime times square root x plus y, plus the second y square term remains as it is. And what is the derivation of the square root? It will be 1 by 2 square root x plus y. And what is the derivation of this? Derivation of x is 1 plus y is y prime. See, there is product rule, chain rule, all that, everything together, you know. So this is the solution of only this AB. Minus 2 comes down to be 8x equals y prime. Now let's try to rearrange. Now you can do one thing. What I would do is, uh, since the denominators are not desirable generally, I'll just multiply 2 square root xy throughout. So I'll multiply this by 2 square root y. So what happens is it's 2y prime square root x plus y. This entire thing is multiplied by, I'll write it over here. It's all multiplication. So 2 square root x plus y. Then over here, now this, if I multiply it with 2 square root x plus y, denominator numerator cancels, and you will have only the top terms, that's the numerator terms. Y squared 1 plus y prime minus 8x. Then again we have 2 square root x plus y equals, lastly we have y prime 2 square root x plus y. Even you can do it without this simplification. It's just that this fraction will remain. When it goes to the other side, it might be a little, confusing. Now then, what else? Group the y prime terms. There is one y prime here, and y prime here. What I would do over here is, first I'll rearrange it. Let's simplify how much I can, because the numbers can be multiplied. And let me do it a little simplified form. So 2 and 2 is 4. Y. What about square root x plus y square root x plus y? If you have square root a times square root a, it's power half and half, it's a, isn't it? Now here what happens is, this term becomes x plus 1, x plus y. The square root cancels off, you get a whole term. And then lastly, I'll write the y prime term here. Plus, here there is y prime. Now this entire thing, you can see, what you can do in this case is, I'll multiply y square inside. Okay, it'll be y square plus y square y prime. This is y prime of x. This is what we are solving. I'm not sure what's there in the solution set. They may not have multiplied this. They might have. No, you have to multiply, because this is y square. You have to, no matter what, you have to multiply it inside. Then minus 8 times 2 is 16. Then what do you have? 16 x square root x plus y. That is equal to y 2 times y prime square root x plus y. Now let's look into the y prime terms. First term y prime, this is also having y prime, but this is having y prime. Now instead of moving all these both to the other side, I'll just move this inside and this to the other side, because this doesn't have y prime. So that is going to look 4y times x plus y, y prime, plus y. Okay, now this y square also moves to the other side. Sorry, I just didn't realize about this. It's only this term. So it'll be y square y prime, and this one comes inside. It's 2y prime square root x plus y. This all will be equal to what? This to the other side will be positive x square root x plus y. And this to the other side would be minus y squared. This is the answer. And now when I remove this y prime, and y prime common outside, you're getting a huge term inside. That is x plus 2, x plus y squared minus 2 square root x plus y. That is equal to 16x square root x plus y minus y squared. Now the final answer over here would be this, all the terms to the other side in the denominator. 16x square root x plus y minus y squared divided by 4y times x plus y squared minus 2 square root x plus y. I hope this much is all clear for everyone. That is the final answer. Now it's very lengthy, isn't it? But See, it's all about differentiation, derivation of this using on both the sides using the product rule, chain rule, and all the rules which are required. Then we search for the y prime terms, group them up, and just take all the remaining to the other side. So here you can see that's the answer. Now look over here. Answers, it's almost same. Yeah, it's the exact same answer, right? Yeah. Okay. Just a little bit of rearrangement is changed. I've not written it in the order, but that's the same answer. So this is how we solve it up, guys. And see, always remember, it's better, see over here, which I've written, to remove this denominator. When you have denominator, when you take it to the other side, it's fine. You can keep it like that. But especially over here, it would have two of these terms would have denominator. It will be messy, you know. It will be very, not so clean as this answer. That's why. But if you are really getting confused, yes, absolutely can do that. Okay. Now then, again we have cosine, sine, and everything. Now this is similar to, see, this cos x plus y. This x plus y is like a, okay? It's like cos a. Don't think, okay, this is multiplied here. No, this is degree. This is entirely different. Now what do we do over here? Product rule again, okay? Now, you know, if you want, you can remove this minus y squared to the other side, will be plus y squared, but that doesn't help us. Like, I mean, yeah, it's just going to be one term over here, two terms over here, but that doesn't help us at all. But if it was, like, say, divided by y, then we take this to the other side, it'll be helping us much more, you know. That's why we, you know, in one of the problem, we removed it to the other side. Now, this problem here, x, okay, first let me write the rule for product rule. A prime b plus ab prime, you know, I just make it a habit. Doesn't matter, I know the rule in my mind by heart, but just write the rule. It's much easier, you know. You will never tend to do any mistakes. Let's solve the first term. This is the first term, this is the second term, a, and this is b. It'll be 1 times cosine x plus y. This is added to x into, what is the derivation of cosine? It is minus sine x plus y. Hope this is clear. Then this minus y squared derivation would be minus 2y prime equals a derivation will be 0. Now we will just rearrange how much we can. Here it will be, see, now did I miss something? Oh yeah, absolutely, I missed a very important thing, guys. What is it? Chain rule for the b term. A is x. I derived minus sine xy multiplied by what? Whatever is inside I need to derive, right? Multiply by 1, x derivative is 1, plus y prime. Then we have this minus. So this is an important term which I missed. 1 plus y prime minus 2y into y prime. So there are two y prime terms. Now this is another bracket for the sine. Now let me multiply this x inside. It will be cosine x plus y. Then over here we have minus x times sine x plus y. Okay, now see, this is a little bit tricky. What I can do is, I'll do it in two steps, okay? I've just rearranged the left side term. See this minus I've written over here with this x and this entire thing is multiplied here by 1 plus y prime, which I've still not solved. Okay, I'll do it in the next step. Here it is minus y into y prime equals 0. Now this I'm going to multiply here and here. See, this left side is entirely a single term because this minus is over here and this is a variable. So this becomes a term and then we multiply it inside. I hope this is clear. See, it's like a b prime, right? This entire thing is b prime. So we will, all things are multiplied, but there are two terms here, right? Because it's plus, but this is not two terms because this is like sine theta. It's a single angle itself. It will be for sine itself. So cosine x plus y minus, now I multiply this here, it will be x sine x plus y multiplied by 1 is the same term, but now we will have x sine x plus y, and then we will have y prime. Can you see this y prime is there? minus 2y into y prime equals 0. Now this and this only have y prime, all the other terms over here itself. Now since these both are negative, I'm going to take these both to the other side. Cos x plus y minus x sine x plus y, that is equal to 2y y prime. This will be plus x sine x plus y and y prime. Now let me remove the y prime common out. You're going to remain with y 2y plus x sine x plus y. Okay, then left side we will have cosine x plus y and minus x sine x plus y. Now let's take this to the other side. It'll be the numerator is the same as above, x plus y minus x sine x plus y. Entire thing is divided by, okay, it's a crooked line, but see, this entire thing will be just divided by this term 2y plus x sine x plus y. Now you can write this first, and next after this you can write plus 2y as well. It's just placement doesn't matter much as long as the answers terms are correct. That's the answer. That is all y prime. Again, a lengthy problem. That would be the final answer. You can see that's the thing. See, over here they have written 2y later. This sign is written first. That's all right. So that's how we solve it. And two more problems to go. Let me do it quickly. Now we have natural logarithm. I hope you remember derivation of natural logarithm is 1 by x. Okay, ln x. It's called as ln x or ln x, anything. Natural logarithm is the actual term. Now let's use the rules. Derive both the sides. It'll be e to the power 4y. Derivation of e to the power anything is the same term, multiplied by the chain rule. That'll be 4y prime. So derivation of 4y is 4y prime minus. Now derivation of natural logarithm will be 1 divided by y squared plus 3. But here, after this, whatever chain rule, you have to multiply it up, isn't it? So it will be 2y y prime, because 3 will be 1. This is all equal to right side derivation of 2x is just 2. Now how do we simplify? We got the y prime terms already. It's pretty simple problem. Here you can just take y prime and take everything to the other side. It's fine, but can you see there's a denominator? It's not desirable to have the denominator, right? So what we will do is, let's rewrite these terms. Before we rewrite, see, this all plus and minus will divide each term. So this is one term, one term, one term, right? Let's all multiply the other two terms by y squared plus 3. So here, what's going to happen? 4, I'll write it first. Power 4y, y prime. This is all multiplied by y squared plus 3. Now here you don't have to multiply, because when you multiply, this denominator gets cancelled. So you're remaining with 1 times this much will be 2y y prime itself equals 2 times y squared plus 3. Now which are the y prime terms? These two, right? I'll just take y prime here, and you're remaining with 4e4y. Its power, okay? Y squared plus 3. This is in a bracket. And then minus 2y. I'm not going to multiply this inside because anyways y prime is outside itself. I just took it out. Equals 2y squared plus 3. Now take this to the denominator of the other side. Y prime will be equal to 2 times y squared plus 3, which is a quantity together. And 4e4y, y squared plus 3 minus 2y. This is the final answer. So this is how we would solve natural logarithmic problems. You can see that's the same answer here. Sometimes, these terms might be rearranged, but as long as you have written the correct quantity, that's more than enough. And the final problem here. Okay, this is again something only exponential. We have done this before as well. Let's quickly solve it now. It's just that square root and exponential are there. Here we have to use product rule. A, this is the first term, a, b, that will be a, b, that is a prime b plus a, b prime. Now what happens here is e x squared, that is as it is, multiplied by 2x. Why? Because when we derive the first term, e to the power x is e to the power x itself, but we have e power x squared as it is. Then we derive the chain rule, whatever is above it, whatever the power. If it was only x, we write multiplied by 1, which we don't write, it'll be just this term. Next, it'll be plus, oh no, I have to write the b term, right? See, I would have forgotten. Since I have the rule here, I can easily check with it, right? This is all a prime, b will be y, plus, what is a? It is ex squared multiplied by b prime is y prime. That's it. B prime is basically y prime. Now minus, what about this side? It'll be 3 square root x derivative. What is the answer? It is 1 by 2 square root x, isn't it? So I'll just write over here divided by 2, 3 divided by, it's like 1 by 2 square root x. It's just the denominator, right? So I'll directly write it over here, y squared plus 2. But now then the chain rule, whatever is inside must be derived as well. It'll be 2y y prime, that is equal to 2x plus 0. I'm not going to write it because this constant terms are 0, derived as 0. Then here we have got prime. Here we have got prime. But before that, we have a denominator which we multiply throughout. So let me rearrange this. 2xy e to the power x squared multiplied by again 2 square root y squared plus 2. Plus again over here it is ex squared y prime multiplied by 2 square root y squared plus 2 minus, what do we have over here? It's 3 times 2, 6y y prime. Now I don't write any denominator or multiplying because when we multiply 2 square root y squared plus 2, it cancels off. That is equal to, what is at the right side? 2x multiplied by 2 square root y squared plus 2. Now then, let's look at all the y prime terms. There is y prime here. There is y prime here, right? Let's leave those two terms here, everything else to the other side. So ex squared y prime, and this 2 I'll write it out over here, square root y squared plus 2 minus 6y into y prime will be equal to 2 times 2 is 4x square root y squared plus 2 minus these two. Let's solve it up over here. 2 times 2 is 4 x y e to the power x squared, this is power 2, square root of y squared plus 2. I hope this much is clear. Now y prime and y prime, there were two terms which are over here, then everything else to the other side. Let me take y prime term outside. Now if you're thinking, yes, you can directly remove y prime and write this divided by the remaining parts, but I'm just doing the steps here so it's very clear. See, I will tell you after the final answer what step you can easily avoid in a minute. Now y prime is outside, so that is not there, and over here we have y power 2 plus 2 minus 6y only, y prime is taken out. 4x square root y squared plus 2 minus 4xy e to the power x squared square root y squared plus 2. Now let's just divide all this. It's y squared plus 2 minus 4xy e to the power x power 2 y squared plus 2 divided by 2 e to the power x squared square root y squared plus 2 minus 6y. Is that okay? And that is y prime. Now what I was saying is from this step here, you can directly jump over here. The right side will remain the same. Now here if you remove y prime and y prime outside, this is going to be only these two terms omitted, right? See here 2x e power x squared square root x y squared plus 2 minus xy. You can directly write this skipping this term, but just for understanding purpose I've written all the details. So that would be the answer, and that's it. So over here they have, okay, now you can see one thing, there's some changes here. What is the changes? This is correct, but they have removed a common factor of 2 outside. What do I mean? There is 4, so you can remove 2 outside and you are remaining with 2x and this term minus 2xy and this term. Even down you can remove 2 outside, so you're remaining with ex squared and minus 3y. So then this 2 and 2 is cancelled. But as long as it's considered, you can do that. Like you can divide all the terms by 2 directly. So this will be 2, this will be 2, this will be 1, and this will be 3. You can even directly do the step directly as the answer as 2x squared and so on. See whatever is mentioned here. You can see this, that's the final answer. Or you can leave it as 4, what I've kept it, that's the same thing. It's just that it's not the simplified form. They have not asked the simplified form. It's just the y prime they want, right? But if you see these common terms like all multiples of 2, just cancel, divide all these terms by 2, and here you go. This will be the final answer. This is the end of question 18. Guys, a quick reminder, you can subscribe my channel for free. There's no cost whatsoever. If you subscribe, it will really make a lot of difference for my channel, and I really appreciate it. I look forward to seeing you all in the next video explanation. Take care and bye bye for now.